Hi, everybody. Okay, so we have now talked about all the different kinds of biochemical compounds that we need to talk about in this chapter. If you take a look, we have all the inorganic compounds. They have C and H, or they are lacking either C or H or both. Organic compounds have both C and H, and then we have carbohydrates, lipids, and proteins. And we can summarize all of the different pieces that we need for classifying or categorizing them on this slide. So if we take a look, we have the inorganic compounds, right? They have either C or H or neither, but they do not have both. On the other hand, we've got the organic compounds that have both carbon and hydrogen. So if you have a molecule that is missing one or the other, you automatically can classify it as inorganic. If it has both, then you have to move over to this side and look at the organic compounds. You have three kinds, right? You have the carbohydrates, the lipids, and the proteins. So once you decide that it has carbon and hydrogen, you have to ask yourself, is it a carb, a lipid, or a protein? Well, we can get the protein set aside really quickly because if they have an N, the molecule has an N, you're automatically in the protein category. If you don't, then you're either a carbohydrate or a lipid. Now, carbohydrates have carbon, hydrogen, and oxygen, and there's exactly twice as many H's as O's. And lipids have carbon, hydrogen, and oxygen, but there aren't exactly twice as many H's as O's. You may also be looking at their shape. Carbohydrates are in rings, 1, 2, or 3. Lipids are generally in the shape of a giant E. And proteins are the ones that are long chains or single units, but all with nitrogen. So we're going to take a look at some molecules and see if we can classify them. So let's start with C6H12O6. Now we have the first question, is it organic or is it inorganic? Well, it has both C and H, so it's organic. So it's either a carbohydrate, a lipid, or a protein. Which is it? Well, we can rule out proteins because there's no nitrogen. So we are in either carbohydrate or lipid. In this case, we can see that there are exactly 12 hydrogen and 6 oxygen. So there are twice as many hydrogen as oxygens, and so we say this is organic and it's a carbohydrate. It's not drawn out in a structural formula, so I would not expect you to know that that is a monosaccharide. Let's go on to number 2. All right, is it organic or inorganic? Well, it has C and H, so it's organic. Is it a carbohydrate, a lipid, or a protein? There's no nitrogen, so it is not a protein. So it's either a carbohydrate or a lipid. Let's look at the number of H's and O's. There's 22 H's, 11 O's. That's twice as many H's as O's. This is also a carbohydrate. So you would say this is organic, it's a carbohydrate. I wouldn't expect you to know that this is a disaccharide. Number 3, is it organic or is it inorganic? Well, it has C and O. There's no H, and so it's inorganic. We are done classifying number 3, inorganic. All right, let's move on to number 4. Is it organic or inorganic? Well, it has C and H, so it's organic. Is it a carbohydrate, a lipid, or a protein? Well, it has C, H, and O. There's no N, so we can rule out the proteins. That leaves us in either the carbohydrate or the lipid. There are 12 hydrogens and 2 oxygens. Is that exactly twice as many hydrogens as oxygens? No. So that is a lipid. Moving on to number 5. It's got C's and H's and O's, and that's what's in that molecule. So is it organic or inorganic? It's organic. It has C and H. Is it carbohydrate, a lipid, or a protein? There's no nitrogen. You can rule out proteins, and that leaves us carbohydrates and lipids. We could count up all of the hydrogens and all of the oxygens, or we could just look at its shape. It's in the shape of a capital E, and so it's a lipid. Number 6, is it organic or inorganic? It has C's and H's, so it's organic. And if we look really carefully, it has no nitrogen. So again, we're either a carbohydrate or a lipid. And if we counted it, we would find that it has 12 hydrogens and 6 oxygens, but we don't even need to do that. By its shape, we can tell that this organic molecule is in a ring, and so it is a carbohydrate. Number 7. It has C's, H's, O's, and N's. Is it organic or inorganic? It's organic. It has carbon and hydrogen. It has C, H, O, and N, so we know automatically it is in which category? It is in the protein category. And because there's only one N, is it an amino acid, a dipeptide, or a polypeptide? It is an amino acid. And number 8, it has C, H, O, and N. Is it organic or inorganic? It's organic because it has C's and H's. Is it a carbohydrate, a lipid, or a protein? It's in the protein category because it has nitrogen. So we count the number of nitrogens, 1, 2. So it is a dipeptide. So we would say organic, protein, dipeptide. Number 9. It's really small on the screen, but automatically you probably can tell what it is. It has C's and H's, so it's organic. It has C, H, and O, and no N, so it's not a protein. And we can tell by the shape of rings, it is in the carbohydrate category. And it has 2 rings, and so it's a disaccharide. And finally, number 10, it has C and H, so we know it's organic. It has C, H, O, and N, so we know it's in the protein category. And we count up the N's, 1, 2, 3, 4. That's 3 or more. So we are looking at a polypeptide. And that's how you will use this information to identify molecules and how they're classified.